Hello everyone, welcome to nidya.org, the Igniting Innovations. In this video, we are going to see the Consul cluster, a hands-on journey, building fault-tolerant and resilient microservices. If you want to access the source code for this series, you can access via github.com/nityananda/consulx. And also I am suggesting to please visit nithya.org or nithya.io for further more information. If you see to today enterprise world, there are tons of problems exist in distributed systems. If you take example, so this is a normal scenario which is exist in enterprise world today. So there are load balancers which is getting the calls from external world like browsers or devices, and this in this example we are taking e-commerce sites and the further load balancers, correct? So the load balancers will hit that your e-commerce sites and from and which will choose the one of the instance, and then it will forward that calls back to the business logic layers, and that is also exist behind the scenes with the load balancer, and the business logics will go and get the details from database servers. So this is a typical normal enterprise scenarios which was exist, but actually today it's not like that. So if you see that there are plethora of services, microservices exist, and it is needs to communicate in many systems. For example, the UI layer want to communicate with identity services. Once the identity is actually confirmed, then it needs to talk to the order services. Then once the order services might be able to talk to other three services like product, the search API and fulfillment service. And even though there may be a fulfillment service might need to talk to some third-party services. So such a complex scenario, how that today's world exists, is it like if you see that, so if you take the example, there are tons of identity services might run at the same time, and so it needs to understand what are the services it can call, as well as what are the services it can be get consumed from my microservices. So for that in each microservices you need to put each load balancer in every sections. So it's very cumbersome to handle, as well as the load balancers might get suppose if one of the instances failed, the whoever is consuming, they might get some errors like 503 and service unavailable, and also doesn't know how to remove the failed nodes from the load balancer and automatically add back to the load balancer. It is a very difficult in today's scenarios. That's what actually we are going to resolve it. So before going into what Consul provides to us, so it provides the API gateway for us. So that means it will act as an entry point for any calls which is coming to the Consul cluster. And also it is going to the service discovery. What does it mean? That whatever the services is getting added or removed, it understands natively, and also it will provide the information to the backend servers and also foreground servers. And also it provides a very neat way to register and deregister the services with a microservice platform. And also the challenge behind the enterprise services, suppose if you are running more than 500,000 servers, and how we are going to monitor at the same time, how we are going to collect the logs, how we are going to check the health checks, all the things is a very cumbersome today, and it is solved by Consul. And also the failure detection. So how it is going to natively understand, hey, my services are failed, and how I am going to remove from the servicing, and as well as how it is going to be come back to the native state. That is the biggest problem today exists. So we are actually using so many monitoring tools, and then once the failure is detected, and you are going to manually go and check that the problems, and then you are withdrawing from the load balancer and repair it and put it back to the cluster. So it is very cumbersome today, and we are going to see how it is going to resolve these problems. And next is The Consul provides multiple control layers. How we are going to control that entire clusters? You can use CLI, you can use HTTP APIs, you can use RPC internal calls. So it's a very robust controlling system. You can easily control your entire cluster, even thousands of machines at your ease, and you can do it from anywhere. And also it will provide the interactive portal which you can see the what are the services are running, what are the services and failure states, and what are the key value stores are added. Everything you can see in the interactive portals. It's a very interactive, so you can easily manage. Even you can use it the same HTTP API to control the same, but this is very important for administrator, at least if you are not automated. The biggest thing is how we are going to implement or invoke your security modules at ease. That is also Consul actually will involve with the help of the other tools. And it is also you can easily plug and play with the throttling mechanism and auto scaling mechanism from many vendors. So it is very easy, and also it can easily give information regarding your auto scaling. The another biggest things which I already discussed in the previous slide, how we are going to implement native load balancing instead of putting load balancer in each microservices world. It is very tough to handle such kind of things. The Consul is natively actually understanding that DNS, and then it will select your services at ease. So that's what actually we have to obey with that. So now we are going to see that each features in slide by slide, so it will be help you to understand what is mean by that. For example, as we discussed, if you take the load balancer, correct, so it needs to communicate to identity services and needs to communicate to other services. Suppose if your load is more high, you like to add 2 more services to identity services, and also needs to understand, UI layer needs to understand, hey, there are 2 more nodes are added, so distribute my load to across that nodes also. So that is very important factor. So for example, if you want to add 2 more nodes to the identity services, how UI layer, even every microsystems, it can be understand and to talk to these new layers also. That's actually service discovery. So the services are natively discovered and auto discovered from the Consul clusters, and anybody, suppose in the next few seconds, it's a so near real time, you can call that same microservices, and you can see that new services added in the next few seconds. So that's a very important features of that service discovery. So we will see in action in a workshop sessions. So let's see the next feature. The next feature is, as I told, failure detection. So if you have the thousands of servers and then you want to see the detection, which node is actually failed and which node has to be removed from the load balancer, so that no customer experience will be compromised, correct? So for example, so as I'm taking the same example, UI layer and identity services and other services, correct? So for example, there are few nodes which is from identity services are failed, but whenever it's UI layer actually asking for identity services, so the it will act in the either round robin mode or list connection or something. Some scenario, the failed nodes also will get served, but in Consul it is not going to happen, because once it's detected in a few seconds, these 2 failure nodes is getting removed from the load balancers, and it is not going to show the other nodes. And so the UI layer never gets 503 or 404 errors, because so it is only serve the healthy nodes instead of failed along with the failed nodes. So it will only serve the healthy nodes which can give a response in a few seconds. Okay. The important features is native load balancing. That is, in each section in the world, you have to put your load balancer to serve and distribute the load across the microservices. But here you don't need it, because Consul itself, it provides that native load balancing via DNS result shuffling. So how it is happening? So it understands if you are calling some DNS API, like for example order.service.console, that means it understands natively and it will choose in very easy manner, in distributed way. It will choose one of the guys and it will give the result back. So it will not hurt each and every services if it is having a load. So it will choose only the best services can be respond back. So that's a very important load balancing. So we are going to see in action in the workshop sessions. Let's tune it. The third most important feature is the key value store. So it provides the dynamic global configuration management and reactive configuration. What does it mean that? So in each microservices, there might be plenty of configuration files, correct? So based on the configuration file, your service actually needs to interact with other services. It may be a limitations, maybe a SQL Server configuration settings. It may be another set of services which is running in third-party world. So everything it is managed by configuration today, is it? So that configurations, if you want to, suppose if you are running 500 servers, how we are going to change the configurations at ease, and how it is going to react with in real time. That is also a biggest challenge. Consul, it's actually natively supports the key value store and reactive configuration management. That is mean by if you change anything in this key value store, the next second what are the things actually it's looked upon the configuration file, it will be changed, and also your service will get restarted, and then automatically your configuration will get affected in near real time. So even it might not take more than few nanoseconds. So that's a very important feature of the console. It's a awesome key value pair. So you're going to see that in action in our workshop sessions. The another most important things, if you have multi data centers, and then your services actually spreading across the multi data centers as well as the multi blade servers. So how that the URL layer is going to select which is my nearest network coordinates, correct? It is very important. Otherwise you will get so much latency and you will get less response and performance, correct? So how it is going to resolve by this? So Consul is natively understands who is the long distance nodes as well as who is the nearby nodes. So it understands natively. So it is having an entire benchmarks, and then whenever the URL layer calls the identity services, it will choose the nearest nodes. That's the beauty of that network nearest nodes using network tomography computations. So it understands every few seconds, even every request and response, it is filing that benchmarks and handling in Consul servers. So we will see in action everything. And then now we are going to discuss about the Consul architecture, how it is actually shaped to perform the explained features. The first thing is the Consul actually acting as two modes. One is Consul servers and Consul clients. So what is the Consul services? Consul services for high availability you should maintain one leader and two followers. What does it mean that? So always all the entire writes will go to this Consul leader, and then it will replicate on TCP 8300 port to the followers in real time. So whenever you write something into the leader, automatically it will replicate into the followers. But you might have a question, what happens if the leader dies? So that's what actually it's helping by consensus raft protocol. So what it does actually, so once the leader dies, and it is actually conducting voting. The conducting voting via doing a raft algorithm. So what raft algorithm is do is, and also it is doing with the quorums. So the quorums, the policy is you should have n plus 2. That means you have one, then you should have the two backup systems, which is like a followers. So if one guy dies, and it automatically identify and conducting the votes, and who is getting the more votes, it will elect as a leader. And then the next time the failed leaders can be joined as a followers. So we will see in action. And then once this like new says, it will forward the leader forwarding. And as I told, So there are the console can act as the servers as well as clients. If you see the bottom layers, this is the client nodes. What is meant by client nodes? Client also can act as a dummy web portal nodes as well as a service nodes, which is actually order services or identity services, whatever you call it. So it is actually running your services. That is also a console nodes, because you should install the console in every nodes, because if the console actually always monitoring your nodes, and also it is doing gossiping using the port of 8301. What it does actually, so it is not actually you are pinging the nodes each time for the health checks. What it does, each console is going to monitor their own localhost services, and then if anything problem, even if it is a pause or failed, so it will spread the gossips to gossip protocols. That gossip protocol is nothing but the SERF protocols, which is also a product for from HashiCorp. So what it does is actually it is spreading that rumors, and also it's communicating back to the entire cluster, even including the servers, via the RPC mode in TCP 8300. So the surf which is running on 8300, which is actually the surf which is running on 8301, but it is communicating to server side with this 8300, which is the listening port of servers, so that the every gossips actually reaching the entire clusters. So every nodes understand that what is the status of each node, correct? So that's a very beauty of the things. And I want to actually notify you, so in this workshops, even every workshops, I'm going to use CentOS VMs, but the problem but there is no problem is using the other distros in Linux like Ubuntu or Amazon Linux or even Fedora. So definitely it can easily applicable for any other Linux distros. So try it, nothing is actually a problem. If you have any problems, please mail me on info@nithya.org. So I will help you with pleasure. The next, so in the previous slide, we have seen that these are actually, it can run in a single data centers. What if you want to know the architecture, how it is going to act in two data centers? So if left side is a one data center, another is two data centers. I want to know that, okay, what are the services are running, what are the current states of the each microservices. I want to understand it, because I might need to maybe a load balancing between the two data centers. Even I might use for active passive modes, or I can use for active mode. So how it is happening? So you know already in single data centers, the gossips are rounds in LAN gossips in 8301, because here the client and servers are involved in the gossips systems, but in between the data centers, only the servers is going to act in the gossips protocol. So the one gossip is going to act in 8302 in TCP and UDP mode. So what it does actually, the two servers between the two data centers is going to communicate it and spreading the gossips. That's a very important difference while handling in single data center, while handling in multiple data centers. Okay, so before jumping into the actions, I like to invite you to listen or read the following things, because it's very important, because we are going to see many things in action, but if you know the important theoretical concepts behind the scenes, it will help you to understand what I'm going to do in upcoming work sessions. So first you see that I want you please understand what is called CAP theorem. CAP is nothing but C is for consistency, A for availability, P for partition tolerance. So I'm not going to explain what is the entire CAP theorem, but it is meant for no distributed system is safe from network failures. So you should embrace the failures, you should expect the failures, how we are going to act on it. So for example, in consistency, correct? So every reads which is you are getting request from the outside world, it should give a most recent right data. It should give always consistent data. It should not give, otherwise it should give only error. So it should not actually do the bad things like drifted data. Another is availability. Is that every request should get a response. That's a very important. And also that response might not be give a most recent version, but it will give a eventual consistency information. Correct? But that whatever any cost, it should available. That's a very important factors in availability. Your system, cluster system, multi-node system should obey these policies. The next is partition tolerance. So what it does actually, your system should, the data should be distributed along the partitions. Even one partitions actually might have some multi replicas. So in any cost, your system should continuously operate. Your continuity of the business should operate always, irrespective of the some partition failed. That's a very important aspect, what is called partition tolerance. So this consistency, availability, partition tolerance makes the highly resilient and fault tolerant systems and highly performance and scalable system. So it's the CAP theorem you should understand natively. So please go and check with that from the particular URL from in Wikipedia, or you do search in Google, you will get multi-list of results. The next is I'm asking to go through what is called RAFT. RAFT is nothing but a consensus algorithm for managing replicated log. What is that? So if you wanted, for example, if you have multi nodes, is it, or you want to know that what is the coherence between these systems and how I can elect the new leaders if someone fails. So each and every second, using RAFT algorithm, so it is sending the signals across the cluster. So I understand, okay, something is going on, so I need to take action. So it is doing that, managing a replicated log. So it will help us to build highly reliable and large software systems. So if you want to see in a graphical mode, this is the nice link, the secretlifesofdata.com/raft. So this link will provide the information about the raft systems. Correct. So please try it, and it is very nicely explained in the portal, and also you can get more theories from Wikipedia or any other systems. And another thing, the main important algorithm is called consensus protocol. So the consensus protocol is that what it solves, the fundamental problem in distributed computing and the multi-agent system is to achieve a overall system stability. Without the system stability, whatever do the beautification is go for a toss. Correct. So, and it needs to actually work with a faulty process, because anytime you cannot predict all my system always idle 100% working. So you will have some faulty process. How we are going to work with the faulty process, and how we are going to compute, okay, there might be some bad things is happening, and how we are going to withdraw from the services. That's a very important. So the consensus protocol will help you to understand it. The another beautiful things of Consul is a gossiping. So the gossiping is that happening via in the cluster is actually because of surf system. Surf is actually another product from HashiCorp. What it does actually, it natively understands the membership system of the cluster, and also it understands the failure detection and even broadcasting via gossiping. So gossip protocol, it's very actually matured in nowadays, and it is very fast. And trust me, and it can spread the more important information across the cluster at ease, and is very lightweight. It will not take your bandwidth much, and that there is some limitations. You should understand that if you have so much things, you should actually logically grouping to avoid the overheads. But so I am asking you to go to the https www.serf.io. that is will take you to the HashiCorp site, and it will explain everything to you. Okay. So to be with my actually in my workshops, you should have a prerequisites, which is you should have the desktop or laptop with Windows OS installed. So but it will not be a big problem if you have that Linux, Ubuntu or Fedora operating systems. I don't have any problem, so you can easy to follow. But as of now, I'm expecting, assuming you are a Windows user with some VirtualBox enabled. So the second thing is you should enable, because we are going to play with many virtual systems. So you should enable a virtualizations at BIOS level. Third one is, yes, definitely you should have internet connectivity, because we need some updates. We need to actually get some binaries from the internet. So you should have the internet connectivity. That is a must. And also you are going to play with the administrator access, because it's very important, because you cannot virtualize the applications without administrator permissions. The fifth and most important point is, I'm assuming you should be installed the Vagrant and Oracle VirtualBox in your system, because these are the backbone of virtualization in Windows system. So because we are going to play with naturally with Linux, so I'm assuming, because if I go directly with the Linux system, so the Windows system will be in a problem. So that's what I took the route. So I'm majority of the users, I'm assuming you have Windows systems, and we are going to play with the Vagrant and Oracle VirtualBox, and that's what you should have this thing. So once you set up the prerequisites, so please make sure and you connected your system with power, because we are going to play so many things. Let's tune it. Thanks for watching, much appreciated. We are going to play now. So in the meantime, if you want to access the source code, you can access from nityananda/consulx, and also you can sign up for my newsletters. It is nithya.org/sign up. And if you want to interact with me directly, you can use info@nithya.org. I am always available to answer your questions. Let's play. We are going to play very important things. Please be with your laptop in a switched on mode. Have a great day.